Welcome to this lecture on bevel gears and worm gears in the course Advanced Machine Elements at Luleå University of Technology. My name is Jens Hadell, and this is the contents that I will be discussing today. The lecture is divided into 5 different parts. The first part, I will give you a very brief introduction to contact and bending stresses in gears. The second part, I will move on to bevel gears and introduce the bevel gears, the applications where you may find it. The third part will deal with the geometry of bevel gears and the forces that are acting on bevel gears. The fourth part, I will move on to worm gears and introduce the concept of worm gears, typical applications where you may find them, the geometry of the gears, and how to calculate the gear ratio. In the last and the fifth part, I will be discussing worm gears and specifically the forces that are acting on worm gears and the efficiency of worm gears. But let's start with the stresses in gears, and there are 2 main stresses found in gears, and these are the contact stresses, which would occur here and here, and these are Hertzian type stresses since you have basically 2 cylinders contacting each other, which gives rise to a line contact, and fairly high contact stresses can arise in gears. The second type are bending stresses. Due to the force that is acting on the gear, you will have stresses here and here in tension and compression depending on where the force is acting. When it comes to contact stresses, the Swedish standard 1871 describes a methodology to determine the forces and constants to be able to calculate the contact stress. In the equation you see the contact stress, a number of constants here and here, which can be determined from the standard, and then there are some constants or some parameters related to the gears, like the width and the diameter, and we have the combined resulting force acting on the gear. Now, the contact stress that you calculate is then compared to the maximum allowable contact stress according to the relation shown below here, where the contact stress should be obviously less, or at least equal, but preferably less than the allowable contact stress. Along the same lines, bending stresses can be determined using this equation, where we have the bending stress, a number of constants, and a number of constants here, and we have the width, the module, and also the combined resulting force acting on the gear. Then, according to the same procedure, we compare the bending stress to the maximum allowable bending stress according to the same relation as shown earlier. So this was a very brief, quick introduction to the type of stresses that you will find in gears, and this is in order to be used later on in the lecture and specifically be discussed in the context of bevel gears and worm gears. So I thank you for your attention.